Picture a place so distant and frozen that no human has ever set foot there. A world so far away that sunlight takes over 5 hours just to reach it. This place exists right here in our own solar system. We're talking about Pluto. Here's a truth most people don't say out loud. Humans will probably never make it to Pluto. Not anytime soon. Maybe never. Reaching this tiny dwarf planet is one of the most difficult tasks in all of space exploration. Pluto sits over 3.7 billion miles from Earth. That's so far away that if you drove a car at highway speed without stopping, it would take you over 6,000 years to get there. The distance is almost impossible to imagine. The only spacecraft to ever reach Pluto was New Horizons. It arrived on July 14, 2015. But here's the thing. It didn't stop. It just flew by, took a quick look, and kept going toward the edge of the solar system. But why spend so much time, money, and technology for just a brief flyby? Why couldn't we send something that would stay and explore? The answer reveals everything about why reaching Pluto is nearly impossible. For decades, Pluto was known as the ninth planet. It sat on the frozen edge of the sun's domain. Scientists believed reaching such a remote world would take centuries. But a rare opportunity came much earlier than expected. In 1964, an engineer at NASA realized something big. Between 1976 and 1978, the giant planets would line up in a rare alignment. This only happens once every 176 years. This alignment would let a single probe visit multiple planets using gravity assists. Each planet's gravity would act like a slingshot, speeding up the spacecraft and saving fuel. NASA proposed an ambitious project called the Grand Tour. The plan was to launch 2 twin probes. One would visit Jupiter, Saturn, and Pluto. The other would go to Jupiter, Uranus, and Neptune. The first probe was supposed to reach Pluto around 1985. But something went wrong. The Grand Tour's cost was deemed too high, the project got cancelled, and Pluto lost its first real chance at being explored up close. In its place came a cheaper option, the famous Voyager probes. They would follow similar paths, but with a more limited scope. Voyager 1 actually had the option of heading to Pluto after visiting Saturn, but NASA chose a different plan. They redirected the probe to fly by Titan, Saturn's largest moon. This decision, though scientifically valid, meant another rejection for Pluto. The reason was always the same. Distance. Pluto is so far away that sunlight is too weak to power solar panels. The Voyager probes use nuclear batteries instead. These generate energy from the heat of radioactive materials. But would this energy last long enough to reach Pluto? NASA decided the risk was too high. The priority became using available power to explore Titan. Interestingly, Voyager's batteries kept working long after the flyby. That was luck. But it didn't change things for Pluto. For years, Pluto was labeled small, lonely, and not worth the investment. But in the 1990s, astronomers started finding other small bodies beyond Neptune. They called this region the Kuiper Belt. And suddenly, everything changed. Pluto was no longer an isolated case. It became the key to understanding an unexplored region of the solar system. A vast area filled with icy objects, asteroids, and primordial comets. Pluto was more important than ever. This is when the New Horizons mission was born. The proposal was clear. Build a small, lightweight, and extremely fast probe. Its goal was to reach Pluto in record time and collect as much data as possible. NASA knew it would be impossible to slow down upon arrival. The entire mission had to be done on the move, like taking a photo from a car speeding down the highway. New Horizons launched on January 19, 2006. New Horizons made history immediately. It became the fastest spacecraft ever launched from Earth. In just 9 hours, it passed the Moon's orbit. The Apollo missions took 3 full days to do the same thing. In 2007, New Horizons flew by Jupiter. It used the giant planet's gravity as a cosmic slingshot. This extra boost increased its speed by about 9,000 miles per hour. The encounter also let scientists test all the instruments. Over the following years, New Horizons crossed the vast emptiness of the solar system. Each day, the distance to Pluto decreased, but the precision required increased. Even a tiny deviation could cause the probe to miss by hundreds of thousands of miles. In July 2015, the long-awaited moment arrived. New Horizons flew just 7,800 miles from Pluto's surface. What it revealed was completely different from what scientists had imagined. Nobody expected what came next. Scientists expected a dull, icy world with no activity, but the cameras showed ice mountains as tall as the Alps. Deep valleys carved the surface. Smooth plains suggested recent geological activity. Pluto was alive in ways nobody predicted. A massive heart-shaped formation became the mission's iconic symbol. Pluto, once just a vague dot in the sky, gained definition, color, and personality. It stepped out of cosmic anonymity to become a celebrity. But the challenges didn't disappear. Communication signals took over 4 hours each way. Any command sent from Earth arrived late. Last-minute corrections were impossible. It was like driving blindfolded, relying only on pre-recorded instructions. New Horizons couldn't enter orbit or slow down. It simply passed by, capturing data in a very short window. Then it continued into the Kuiper Belt. Even today, it sends information back to Earth slowly, but with priceless value. Why not send something that could orbit Pluto? The answer comes down to speed. To arrive in less than a human lifetime, you need to go incredibly fast. But entering orbit means slowing down from over 31,000 miles per hour. That requires enormous amounts of fuel. Manned missions to Pluto are completely unfeasible right now. A round-trip journey would take decades. Keeping astronauts alive would require millions of pounds of supplies. Life support technologies that don't exist yet. The radiation exposure alone could be fatal. Even so, Pluto remains a fascinating target. It shows us the solar system is far from fully understood. Even small bodies can have atmospheres, active geology, and possibly underground oceans. Behind the label dwarf planet is a real world with stories to tell. Today, Pluto is a symbol of human persistence. It represents what seems out of reach but can be achieved with patience and courage. Maybe future generations will witness a spacecraft that stays at Pluto. Until then, we keep looking to the sky and dreaming.